Alright, hi guys. So we're starting a new lesson and we're gonna work on solving quadratics. And the first way we're gonna use to solve, first method we're gonna use to solve quadratics is the square root method. So the standard we're gonna cover is solve quadratic with real coefficients that have complex solutions. And the one we're gonna focus on is by the square root method, and then we're gonna solve quadratics in one variable. What you're going to learn is how to solve quadratics by the square root method, why we solve quadratics, and how to find roots, x-intercepts, solutions, and zeros for quadratics. Okay, so first you need to know what a quadratic is. A quadratic is an equation where the highest exponent is 2. It's an equation or an expression where the highest exponent is 2. So an equation or expression where the highest exponent is 2. And here's an example. So you may have x squared plus 5. That's an expression. Or you might have 2x squared plus 5x plus 3. That's an expression. That's a quadratic. Or you may have 5x squared plus 7 equals something. All of these are examples of quadratics because the highest exponent in each one is 2. The exponent here is 1, but because the highest is 2, it's quadratic. Solving a quadratic, it means to find the value of the variable. Find the value of the variable. And when you solve a quadratic, there are going to be two solutions, or at most two solutions. Okay, so solving a quadratic means to find the value of the variable. And here's an example. So if I was solving this quadratic, I want to find the value of this x right here. Give me a second. Let me get. I'm gonna write this on the side. There we go. So I'm trying to find the value of this x right here. And there are some methods that I need to use to try to find that. Now, one way to solve a quadratic is to use the square root method. Okay, so the square root method is a way to solve a quadratic. The square root method is a way to solve a quadratic. And to use this method, when just a second, guys. I'm looking for my page extender. Okay, so to use this method, you need to have only one variable in the quadratic. You can only have one variable in the quadratic in order for you to use the square root method to solve a quadratic. And so it's a way to solve a quadratic when the only variable is x squared. So when you see only x squared in the quadratic, then you can use what is called the square root method to solve that quadratic. So here's an example. I can use the square root method in this case because the only variable there is x squared. I can go to the square root method. I can use it in this case. because the only variable in this equation is x squared. So you can use that method only when the variable in the equation is x squared. If that's not the case, then you have to go to another method. All right, these next four words, x-intercept, root, solution, 0, they all mean the same thing. Is where the quadratic crosses the x-axis. Is where the quadratic, or just where it doesn't even necessarily have to be a quadratic. It's just where the graph. So let's just replace that period, because this is not just with quadratics. It's with all types of equations. Where the graph crosses the x-axis. And that's what we call an x-intercept, a root, solution, and a 0. And there's something else you need to know about this. And it's also where the y value is 0. Here's your example. If I tell you the solutions to a graph is 2, 5, if I tell you the solution to a graph is 2, 0, and then I tell you it's negative 2, 0, and the root solution, x-intercepts are zeros. If I tell you this is the answer, what I'm saying is if I was to graph this, I would have a point here at 2, 0, and I would have a point here, or we'll just say we're going by 2's, at negative 2, 0. These are my x-intercepts. Solutions, roots are zeros. And what you notice here, the y value is 0. That's how you know you're dealing with an x-intercept, root, solution, or 0. And we'll talk more about this. Right now, we're just trying to figure out how to find it, but we'll talk more about this when we graph. Okay, so let's get into our problems. We're going to say solve the following quadratic. So I am going to use what is called the line method to solve this quadratic. And what the line method means is the variables stay on the left side of the equation and the constants go on the right side of the line. So this is called the line method, and you've probably heard it in some of your other classes, your other math classes. So this is called the line method. So I have a constant that's on the left side. So what it means that if this is a plus, I need to change the sign. I need to take its additive inverse since I have to cross this over the line. And it needs to go to the other side. And then we get 5x squared equals negative 7. And make sure you use your calculator to help you with your integers. And then here, I need to take this coefficient and move it away from this variable. And I need to do the inverse operation of multiplication, which is going to be division. So I divide by 5. And then here, I get x squared equals negative 7 over 5. But I'm not finished because I don't want to know x squared. I want to know what x is. So the inverse operation of something squared is to take its square root. So I'm going to take the square root, and then here we get x, the square root, and the 1/2 reduce each other to 1. So we're just left with x, and then we get, when we take the square root of a quadratic, there should at least, well, at most, be 2 solutions. So I say plus minus negative 7 over 5. And then next we go here, x equals plus the square root of negative 7 over 5, or x equals minus the square root of negative 7 over 5. Now there are several ways you can write this answer. So this is one way to write it, and the answer is not all the way simplified. Or you can write this answer as x equals plus or minus the square root of negative 7 over 5. and that's a full square root. Hold on, let me rewrite that. -7/5. That's one way to write it. That's another way to write it. Or you may see the solutions as when you get up in college, and some other, I can't draw the brackets, y'all, so work with me. You may see the answers as plus, and they're not going to put the plus sign if something is positive, I can tell you that. So -7/5 and comma, -7/5. And I can't close this bracket out, but they're going to be in brackets, guys. Okay, something like that. So that is the unsimplified version of the answer. And these are 3 different ways you can write the answer, and they all mean the same thing. Okay, so the reason why I said that was the unsimplified version, because if I have x equals plus or minus the square root of -7/5, we have an issue here. And remember when we broke down negative square roots, we have a situation where we know this is -1 times 7/5. And then I have to go here and break down that -1. So plus minus -1 is the same thing as I times I, because we know I squared is equal to -1. So the factors of -1 in this case would be I times I. And then times 7 does not have any composite numbers in it. The only factors of 7 are 7 and 1. So I leave 7 alone. 5 is not a composite number as well. The only number there is 5. The factors of that are 5 and 1, and those both are prime. So I can't break that down any. Now remember we talked about with the square root, you take out the house if something has a pair. So right here, because I has a pair, then I can say this answer is plus minus I, the square root of 7/5. And that's what x equals here. So you can go back and rewrite all of these answers as this form. So just make sure the number up on the radical is simplified, and definitely make sure that answer is not negative under the radical. And then you're done. All right, try the next one, and I'll see you guys in class.